Welcome to the WuBlockchain. For the latest blockchain and crypto insights, subscribe to WuBlockchain on YouTube and follow us on Twitter. Stay informed and join the conversation. Today, we are joined by Carl Corrider, co-founder and CTO of Quai Network. Carl, welcome to the podcast. Please briefly introduce yourself and Quai Network.
Yeah, thanks for having me. So, kind of been in the crypto space in about 2012. Got my doctorate from the University of Texas in engineering. Went to work for Consensus, a big player in the Ethereum ecosystem. I did a spin out called Grid Plus, made the lattice one hardware wallet, and kind of part time, I came up with an idea on how to scale proof of work blockchains. And I got a National Science Foundation grant, kind of worked on that part time for a couple of years. And then at the beginning of 22, myself and my co-founder managed to raise money from Polychain Capital, and I've been working on Quai Network ever since. So Quai is basically a scalable proof of work system. We can achieve more than 50,000 transactions per second, but in a setting that looks more akin to Bitcoin. So we use a hierarchy of merge mined blockchains to allow for high throughput while maintaining decentralization.
And Quai Network employs merge mining. This seems to be a concept originally proposed by Satoshi Nakamoto. Can you elaborate on how this works and the benefits it brings to Quai miners and the broader network?
Yeah, so the thing that merge mining allows us to do is create sort of this hierarchy of sharded blockchains. So it's sort of one of the core pieces of kind of how we can scale Quai Network. So basically what merge mining is it's when you make a commitment to multiple sort of blockchains at once. So Satoshi originally proposed this concept with Namecoin. And what he did is effectively Namecoin was a distributed sort of DNS type system. But instead of having its own security, it created a system whereby the Namecoin blocks could effectively reference into the Bitcoin blocks, and then the Bitcoin block security would sort of be imbued upon Namecoin. Now, in that sort of system, that's what we would call a non-reciprocal validation of blocks, meaning Bitcoin doesn't really care about Namecoin's validity. Now, and Namecoin, I guess, does technically care about Bitcoin's validity, but they're not both checking each other. But what we do in Quai is anybody that's running the merge mining is running multiple sort of Quai blockchains. But the blocks are only valid if they're valid in all chains at once. And what this does is it allows us to create a scalable system that also appears sort of homogeneous to the user in terms of composability, interoperability, as well as security. So unlike something like, say, Ethereum, where you can get scalability through L2s, where you have to move money from one system to another, and it has different sort of trust guarantees, Quai sort of lets you do that in all in one sort of homogeneous system.
There are already many layer one solutions on the market. How does Quai Network's technological solution differ from other layer one blockchains, especially compared to the currently popular Tone?
Yeah, so in terms of what Quai has done is Quai is scalable proof of work, and we're actually the first system to really demonstrate sharding in a proof of work system, again at very, very high throughput. So if we were to compare it to something like Ton, which obviously can do better than purely decentralized systems like Bitcoin, it's still running in what would be considered a single shard. Whereas with Quai, we can effectively run up to 255 shards. And if we were to do that, we'd expect a total throughput of about 250,000 transactions per second, which is much higher, obviously, than any other system has demonstrated, especially a decentralized proof of work system.
And some believe that the current market infrastructure is in a phase where supply exceeds demand. What is your view on these opinions, and what kind of support does Quai Network provide for the app development?
Yeah, so our opinion is that not all block space is equal. What you're really looking for in a blockchain when you're talking about block space is you're talking about an economically resilient system that's uncensorable. And with that, you usually get systems that are actually highly robust too in terms of accessibility and uptime. If we look at something like Solana, which is a more scalable sort of American system, but obviously quite a bit more centralized, is they have much worse downtime, right? Every couple months, sort of the chain goes offline for a few days. And if we compare that to something like Bitcoin, which sort of is a property of proof of work, they have sort of very robust, resilient, and very high uptime. So in terms of being decentralized, being censorship resistant, being always online and available, those are things not that other scalable blockchains can't offer. Um, and then the next part of the question was, incentives. Yeah, so we actually have a grants program. I think there's $10 million total in the grants program worth of Quai for people to come and develop apps on Quai Network.
As we know, now Quai Network's economic model introduces two tokens, Quai and Qi. It's rare for public blockchains to adopt such a design. Why was this structure chosen, and what are the respective functions of these two tokens?
Yeah, so the reason for having two tokens in Quai is that we really see um, you can't create a independent, sustainable economic system based off of really anything, but specifically proof of work, without having two tokens. So the purpose of the tokens are to fulfill the needs of a monetary system, specifically having a store value, which Bitcoin has obviously done, but also having a unit of account and a medium of exchange. So the Quai token is what we would consider to be a traditionally deflationary um, store of value in terms of its emission model. And it's also EVM compatible. And you can build applications and finance on it. So that's kind of your programmable store value. And then we also introduced this concept of Qi, which we call an energy dollar. And she has this property that, based off of some incentives that we create, the price of Qi in equilibrium should tend to the price of energy that it costs the miners to produce a Qi. So what that does is it creates an endogenous or in-system token, which is relatively stable in terms of its purchasing power with time. And with that, we can create a competitor to fiat systems like the dollar or the euro, but we can do it in the blockchain itself.
Mhm. And how are Quai and Qi tokens distributed? As you know, there's significant market skepticism towards VC-backed coins. How does the token distribution plan aim to allocate tokens as broadly as possible to the community users?
Yeah, so the Quai tokens, they're distributed majority through the process of mining, much like Bitcoin was distributed. That being said, there is a Genesis allocation that goes to the team and the original investors sort of in the project. Um, but over time, we anticipate that somewhere between 85 and 95% of total supply will actually come through mining. With regards to Qi is meant to be stable, and the process, sort of how Qi sort of seeks equilibrium and maintains constant price, means that Qi is only mined, and there won't be a meaningful, if any, Genesis allocation of sort of Qi in the market. So we see, proof of work mining as one of the most robust ways to come to consensus to create distributed systems, but also sort of one of the fairest ways to distribute tokens over time.
So are there any current marketing or community incentive plans for Quai Network, particularly for users in Azure?
Yeah, so right now we're actually launching our final testnet next week on Tuesday. And if anybody wants to participate in that testnet, they can do so as a miner. Um, you can run a node and use a GPU to mine, and this is a sort of like a fully incentivized testnet. So what we're actually doing is we're creating like a whole economic system wherein the tokens that you have at the end of the golden age will pro rata sort of convert into 10 million mainnet uh, tokens. So there's actually incentives to play many different games here. There's incentives to arbitrage the different prices between Quai and Chi. There's incentives to build applications or deploy NFTs. So if you could run, say, an NFT marketplace and you can make money by people trading NFTs, any money you make is going to convert into some number of mainnet tokens. If you say launch an NFT project and people are willing to pay you testnet Quai for those NFTs, again, whatever money you're able to generate would convert into mainnet tokens. There's also some social programs that we'll be doing, kind of faucet-like programs on Twitter with sort of challenges that people can participate in. So pretty much infinite ways to participate. Just as a speculator, as of NFTs and trying to develop applications or to run in my nodes. There's plenty of ways to participate in the Golden Age testnet. And then once we complete that, we're looking to start mainnet by the end of the year.
That's cool. And you've authored several papers in the crypto space. Could you share more about your research and how it influences Quai Network's design and vision, especially regarding proof of work and scalability?
Yeah, so this kind of goes back to where we started with Quai Network. Instead of sort of incrementally trying to improve on crypto over time, we sort of stepped back and looked at the last 10, 12 years of development. And we said, what is the best way that we can build a economically resilient, decentralized system that can scale to accommodate all of human commerce? That was kind of our mission setting out. Now, to do that, there's a lot of challenges that sort of haven't been done before. One of those, obviously, is proof of work. And we've authored a number of papers on our novel consensus mechanism called PoW, or Proof of Entropy Minima, which is the mechanism by which we can sort of shard proof of work in a causally invariant way that really allows us to create shards.
Mhm.
There's also sort of innovations in this concept of running hierarchies of merge mine blockchain. So being sort of the first proof of work blockchain, we have a paper talking about how that sharded hierarchy works, and state is, seamlessly, trustlessly, and composably transferred from one shard to another. It's really important to understand in the sharded setting, basically the user doesn't see it. So we've written a research paper on how that works as well. Yeah, we've actually collaborated with a couple other names that are somewhat well known in the space, but we've done security proofs on our consensus mechanism. We're working on a multi-chain security proof right now. We've also are working on we've submitting a paper talking about work shares. Work shares is kind of cool in our system. Basically, when you think of work shares, you can think about like shares that you send to a pool. So in our system, what we do is we kind of have that concept of shares in the protocol. What that means from a miner perspective is you have less incentive to join a pool, because instead of potentially, getting paid by winning a block, there's potentially 15 to 20 payments per block that go out for people that contribute shares to the block. So it sort of evens out your revenue much more. It smooths out your revenue quite a bit compared to if you didn't have shares, and makes it so that you don't necessarily have to go to a pool to participate mining, even if you only have, say, one or two GPUs to mine with. So that's also a cool innovation.
And you mentioned the proof of entropy minima. And could you explain how this consensus mechanism enhances security and efficiency in blockchain networks? And does Quai Network incorporate any elements of point?
Yeah, so what PoW basically does is it's really the key that enables us to shard. It's the key that enables us to have a hierarchy of blockchains. It's the key that sort of creates this objective function, which allows people to sort of cooperate in a way that's in Nash equilibrium, rather than something that's sort of not fully sort of economically stable. So PoW is like kind of a big deal in terms of being able to shard proof of work. And it's what allows us to get to scale without really compromising sort of security that people expect from a proof of work based system.
And in your view, what are the biggest bottlenecks that layer one blockchains face when handling large-scale transactions? And how does Quai Network's multi-chain architecture address these issues?
Yeah, that's a great question. So there's several issues, and I would probably bucket them into compute sort of throughput, bandwidth use by the node, um, and those are probably the two biggest issues. Um, I guess there's like a third issue, which is sort of like network bandwidth, if you want to think about, which is the issue of given the number of sort of hops the data has to take to get around the system and the time that it takes between nodes in the system. Um, there is a secondary sort of network bandwidth that exists that's sort of independent of the individual node bandwidths, but is kind of sort of like the aggregate result of how much network you can propagate around the system. So Quai Network really addresses all of these things in different ways. So with sharding, we're able to reduce the requirements on compute because effectively we have sort of independent asynchronous chains progressing that only sort of periodically get synchronously referenced against one of the higher chains, and that's sort of how they communicate. But because they can progress asynchronously, they don't have to compute state on all chains or all transactions at once. They only have to compute state changes on transactions that influence the state in their chain. Um, Additionally, then the implication there is you also can use less bandwidth because you don't have to propagate transactions to the entirety of the network. You only have to propagate them initially to nodes within the shards. Now, there's also an interesting incentive that exists with regard to what we call subnets. And when we say subnets here, they're actually quite different than the sort of Polkadot or sorry, Avalanche definition of subnets. We actually mean subnets from a intranet or an internet standpoint. Basically, when you're mining in Quai, there's a couple different sort of optimizations the miner's trying to make. You can pick to mine in a slice, which is you're mining sort of the prime chain, you're mining this region chain, and then you're mining a zone chain under the region chain. So you're always sort of proposing headers in three chains at once, but you're simultaneously mining them through the process of merge mining. Now, when I have the option to pick a shard as a miner, I want to pick the shard that has the highest reward per hash, but I also want to pick the shard that has sort of the lowest latent set of peers to me in the network. What that does is it creates an incentive that causes the nodes to want to self-organize into topologically optimized sets, which you could consider a geographic subnet. And with a geographic subnet, we're not only improving the network bandwidth because we have a subset of the nodes participating, but those nodes are actually in closer geographic proximity, which means that the data can get around that subnet much more quickly, which means then we can push higher throughput in any one of those subnets. So with the introduction of each shard, the shards actually become more performant because they're sort of incentivized to self-organize into these subnets. Finally, I would just like to mention one of the things that we do is we actually use work shares as a mechanism to encourage efficient propagation of sets of transactions in the network. This really does two things. One, it actually incentivizes transactions to propagate, but the other thing is it does it in a set. So it's much cheaper in terms of the total number of messages that the nodes have to handle, as well as the bandwidth that goes to replicating those transactions as they propagate through the network. You use much less bandwidth and you do much less replication if you do it in an aggregated set using a work share rather than doing individual transaction propagation.
Mm-hmm. Proof of work has often been criticized for its high energy consumption. Given Quai Network's use of merge mining, how do you see Quai addressing the environmental concerns traditionally associated with proof of work, and what steps are being taken to optimize energy efficiency?
So the interesting thing is within the protocol itself, we don't actually have to sort of optimize anything except maximizing throughput. So what you see with something like Bitcoin is wasteful because we use a ton of energy to process a very small number of transactions. So by increasing the throughput in Quai by say 10,000 or more X, you're reducing the energy you're using per transaction. So it's potentially 10,000 times more efficient than something like Bitcoin. That being said, I think Bitcoin, has historically gotten a bad reputation with regards to high energy use because in reality, it has a very synergistic relationship with renewable energy. So here in Texas, for example, we actually get more than half of our energy from renewable energy during the summer. And the reason that we can do that is because there's actually a large mining footprint in Texas. And those miners can basically shut down when there's disruptions in production or spikes in demand. And only with that sort of dispatchability of the miners is Texas able to have such a high degree of renewable energy at its disposal. And I think in aggregate, Bitcoin at this point is about 60% powered by renewable sources. So Quai Network and our incentives would kind of do the same sort of thing.
Mm-hmm. And what are Quai Network's unique advantages in addressing future blockchain chains like privacy protection and cross-chain interoperability?
Yeah, so with privacy, I don't know if I really discussed Chi to a great degree, but Chi, right, is sort of energy dollars. So it's kind of this endogenous, stable token that really creates a unit of account in the system, but it also acts as a medium of exchange. So with Chi, it is built on a fixed denomination UTXO ledger, which means that when you trade Chi, it has cash-like properties. So it's not perfectly untraceable like Monero, but if you're using it in everyday commerce, you would get sort of the same privacy expectations that you would have um, if you used cash. So in Quai, basically, the shards in the chains are fully composable and interoperable, both from a Chi perspective, but also from a Quai perspective with using the EVM. So we are EVM compatible, and then we have exactly one additional opcode, which allows you to do these cross-chain interactions. But from a user's perspective, all they need to know when they're doing a transaction on Quai is really the address or contract they're trying to interact with and the amount that they're trying to send. And if you know those two things, everything else sort of automatically routes through the system. The sharding is actually encoded in the address, so then the chain knows how to handle sort of the relaying of that information through the blockchain.
Okay. And feel free to share anything else you'd like our audience to know about Quai Network or any upcoming plans.
Yeah, I mean, Quai is really trying to build sort of a new scalable proof of work system. Um, and right, our test net's coming up on the 15th, and our main net's coming up by the end of the year. So, 我觉得快跟别的区块链比的话， 是很不一样的，你们应该研究一下。
Okay. Thank you for sharing. And thank you for
OK，
joining
谢谢
us
你。
today. Thank you.
OK，拜。
Bye.